Thank you, Mr. Krishna Kumar, for excellent presentation about the 5 pillars of sustainability. Next, we move on to the presentation. I call upon Mr. Satyendra Dubey.
Satyendra Dubey. I'm the principal consultant for value chain optimization for Asia Pacific, working for AVEVA. And in this role, it takes me across the whole region, and I interact with a lot of clients on sustainability and decarbonization. And I would be happy to share some of the insights which I have gathered during such interactions with them. The topic is repurpose and revitalize your digital landscape, a path to transformation and decarbonization. Because that's what most of the clients are looking for. They're not looking for, you come in and layer a set of solutions which will lead them to transformation and lead to decarbonization. They're looking for, how can I use what I have currently? How can I repurpose? How can I revitalize? In some cases, there might be a need for new investments as well, but how to leverage what you already have. That is the main ask. So the way I'll cover the topic is I'll talk about the industry challenge, which all of you are very familiar with, and the need for transformation. Then we'll try to understand this need for transformation leads to what kind of digital capability which each company should have. And this digital capability, how is it being delivered by the as-is digital landscape? And what can be a revitalized digital landscape as compared to the as-is digital landscape? So you should get a clear idea that how we can move from where we are to where we need to be to meet the need for the transformation. And then we'll discuss some key components of this digital transformation. And then finally, just talk about how AVEVA can enable this for you. Okay, so the challenge is pretty well known, isn't it? The way I put it is, on one level, you have a dynamic market and a regulatory environment. And how does that best illustrated? That's best illustrated by carbon pricing that we see around the world today. A lot of initiatives have been initiated on carbon pricing across the globe. There's a lot of money at stake when it comes to carbon pricing. But the challenge is that each geography is in a different area of carbon pricing. In some regions, there is no carbon pricing. In some, there is nominal one, let's say $5 per ton. And in certain parts of the world, it's even $140, $150 per ton. So there's a wide range. And the expectation is that the regions which have less or no carbon pricing will gradually move towards a carbon pricing which reflects a global mandate on decarbonization. So that is an uncertainty which is coming both from the regulatory side. It impacts the market. It impacts the investment decisions the companies can make. The second aspect is the evolving technology landscape. In an earlier presentation, Aniket was talking about fuel cell technology, and he was highlighting what is needed for it to be successful. The demand needs to be there, the supply needs to be there, and they need to be finely tuned. And it's not just about that also, because you can reach the technology readiness level, TRL9, as they say, for a particular technology. After that, it becomes the case of what will be the scale of that particular technology, at what level it will be adopted. What will be the balance between, let's say, renewables and carbon capture? What will be the balance between a fuel cell technology as an energy carrier and, let's say, hydrogen or ammonia as a possible energy carrier, or let's say a regular EV battery as an energy carrier? So those are the aspects which are not very clear. And this graph which you see beautifully illustrates it. This is from a study by IEA, International Energy Agency. And what it shows is to meet 2030 targets, 80% of the technology is there. Around 15-16% is still to be kind of matured and developed. And for meeting the 2050 targets, there's an even bigger gap. So the companies hence struggle with it. So most of the companies, in my experience, they have kind of adopted a three-phase approach. I don't like using the word phase, but it's like 3 categories of things they need to do. One is unlocking efficiencies. This looks more immediate. Unlocking efficiencies means you become a highly efficient operations. And this is all about energy efficiency, recycling, and those kind of things which pay for themselves. And this seems like a immediate first step companies can take as they go on to addressing these challenges. The next category of things is slowly introducing low carbon emission components into your value chain. And these low carbon components could be feedstocks, low carbon feedstocks, so renewable feedstocks being processed to produce your products. It could be fuel, energy, using low carbon energy to run your plants. It could be producing low carbon products which you can sell in the market. So that's the kind of progressive introduction of low carbon components into your whole value chain. And then comes the last step where we actually go to net zero, and this asks for major capital investments and even operating model changes. So let's say a refiner might stop thinking of themselves as selling transportation fuels, but they might think of themselves as producing renewable energy products like hydrogen. We saw that in the earlier sessions. Or they might think of themselves as becoming a hub for energy kind of services and those kind of things. So the last phase will require a lot of capex and major capital investments. So that's how companies are looking at the transition. And very often they think, okay, this is phase 1, phase 2, phase 3, but we'll come to that towards later part of the presentation as to how companies need to act on all of those at the same time. So if those are the kind of key phases or key categories of actions companies need to take, what does it mean for a digital capability? What it means is, in short term, what you have to definitely act upon is unlocking those efficiencies. And the way to do that is you baseline, then you optimize, and then you strategize with respect to your carbon emissions. So first baseline where you are, then you optimize them, and then you strategize as to how you can reduce them even further. And this graph kind of illustrates a possible journey that you have baselined it, and then you are kind of doing successive initiatives and going on to a net zero over a longer period of time. But this also leads to the second aspect of it, which is the long-term transformation. And here, what you have to do is once you have started strategizing on possible options, you have to evaluate those options, engineer them, and deploy. So the capability which you are looking here for is a green project execution kind of a capability. And what you are trying to do here is you want to reduce the investments to get there, you want to accelerate the time impact, and increase the benefits. So that's what you want to do to be successful. Because like I mentioned earlier, that the market is very dynamic, the regulation is very dynamic, the whole scenario is very dynamic. So if your projects are getting extended, you are facing more risk. And if you are trying to compress it and executing it well, even if there are things which are changing down the line, you have the capability and the capacity to kind of adjust and tweak your strategy to mitigate those risks. So these two things become very important. But the key point is that this is not to be done now and that is not to be done later. In your enterprise architecture, in your digital architecture, you need to have both the capabilities now. Because that's how you will lay a foundation for getting there. So if you have this kind of a view, you are then taking care of all the capabilities which are required to do a successful transformation and decarbonization. Okay, so let's look at what does the current landscape look like to meet those kind of capabilities. So when it comes to unlocking efficiencies, we know that there are a lot of challenges there in the current setup. You might be having Historian, but it's really not a good operational data platform. It's just kind of storing the data from your DCS. It's not the repository, a structured repository of your entire operational data. You might be having APC deployed, like the previous speaker mentioned, but it's like too few, on a very few processes. And those are the key projects which you have done. You might have emissions accounting being done, but it is kind of segregated from your production accounting, and both might be Excel-based. So those are the challenges which you have. The planning also might be a challenging exercise in the current scenario. And when you look on the other side, the whole approach to the capital projects is very document-centric. The way you do your engineering, the design, these are all based on documents, everything focused towards the final handover, and very often that gets pushed, and there are a lot of issues there, and the time to money or time to the full throughput, it always gets extended. So this is not a good scenario for meeting that challenge. Let's take a look as to what a revitalized scenario would look like. The revitalized scenario would have all those capabilities and perhaps some of the same softwares as well, but repurposed to meet the challenge at hand. And some of the examples are, you would kind of unify your production and emissions accounting. And then just to make sure that you have more confidence in your emissions reporting, the same amount of confidence which you have in your production reporting. So that's the idea behind unifying them and kind of bringing them together. Then for optimization, you have gone beyond APC, and you're using actually a process digital twin to not only have APCs at all the places where viable and directing the APCs, but you're also optimizing your overall process. And then using it for energy performance and those kind of things, and emission performance management. And then on the planning side, it's your same planning application, but you can configure the scope 1, the scope 2, and the scope 3 emissions in it, and now start taking making operational plans and taking investment decisions for future, keeping in mind how your scope 1, scope 2, scope 3 emissions will impact, and bring in the economics of that along with the regular economics, and plan for next year and 5 years down the line. So that's how the more immediate transformation would look like if you have these kind of 3 elements, what we call as carbon chain optimization solution. The carbon-aware planning is where you would get ideas on what you need to do for future. You would evaluate those ideas at a purely economic level. And then you would kind of rapidly want to evaluate the designs of those. So you would want to evaluate the renewables, the solar winds, the electrolyzer. If those are some of the ideas you have thought about, you need the capability to rapidly evaluate them. And then actually engineer them and do an on-time execution, on-budget execution of your net zero-driven projects. And then finally deploy it in a very flawless and a smooth handover and get to the full throughput or a full outcome which you desired in the right amount of time. And you can see some of the benefits of this approach. On the left-hand side, you can see the amount of CO2 reduction, profit increase, and the energy improvement a carbon chain optimization kind of solution can deliver. For the engineering efficiency, these are proven benefits, about 50% increase in feed stage, 30% increase in engineering efficiency, reduction in project schedule by 20%, and overall reduction in total install cost. So those are very viable benefits which you can gain on the way to your decarbonization and transformation. Okay, so let's look at each of those components which I described in a little bit more detail, just to give a clearer idea of what is happening. So I talked about unified production and emissions accounting, which is the first step, which kind of helps you baseline your emissions accounting. And the key concept here is very simple. When you're doing production accounting, you're drawing an envelope across your production facility. And what you are doing is you're calculating what is going in, finding out what is going out, and as a byproduct, you're also calculating fuel and loss, because what goes in and what goes out gets balanced by that fuel and loss. And if you look deeper, fuel is nothing but combustion emissions. And the total physical loss is process emissions, solid handling loss and liquid effluents, and unaccounted losses. So just by doing this and having a software which is repurposed and has that capability of kind of doing carbon calculations also along with it, you can come out with a report which is not just talking about production, but is also talking about loss and emissions from your production facility. The reason why it is becoming more important now is if you're following the regulation, last year, SEC, the Securities and Exchange Commission of US, came out with a proposed rule which said that all the companies beyond a certain size have to report their scope 1 and 2 emissions. Scope 3 is also included, but it has some safe harbor provisions, so there can be some inaccuracies there. But the scope 1 and 2 emissions have to be reported along with the financial reporting. So, and that rule starts becoming applicable next year onwards for some companies and for other companies the following year. So the regulation is moving in the direction where you need to own up and be very confident about your emissions numbers. We know a lot of cases where companies have had to re-baseline their emissions number because they discovered the Excel they were working on had some bad assumptions and they missed out on certain things. But doing like this will give you absolute guarantee and assurance to the executives that your emissions number are truly what you are claiming them to be. Okay, so going on to the next aspect of optimize. And here I just wanted to talk about the energy efficiency opportunity for the industry. And broadly, the way we see it is you have 3 kinds of energy efficiency opportunities. So if you are here, you can first go down to what we call as best practice minimum. And the best practice minimum can be delivered through APC optimization, energy performance management, walkthrough audits, and those kind of things. Then comes the CAPEX minimum, which requires capital investments. And this takes a longer time, and it requires some focused studies to be done. And then there's a thermodynamic minimum, which is like based on the R&D developments which are currently going on. So the focus here, especially in the first phase of it, is to capture the best practice minimum. The CAPEX minimum is the engineering side of it, so which is the long-term transformation which I talked about. How to capture the best practice minimum? We believe the process digital twin of your facility is the key to capturing it. Because to capture the best practice minimum, you have 3 gaps which you have to overcome. The gap 1 is the variability gap. So first of all, if your process is highly variable, you will invariably consuming more energy. So you have to reduce the variability. Then you have to move the process to the optimal. This optimal has to be based on the process and the energy costs and all those kind of things. And then comes the best practice minimum, which is based on best operational best practices, best practices around maintenance of your equipment and those kind of things. And all of them can be enabled, supported by a process digital twin of your facility. So APC, optimization, all of them can combine into a digital solution for energy management, which is powered by a process digital twin. And this can address that particular gap. Coming on to the carbon-aware planning, here essentially what you're trying to do is you're trying to move from current gray operations which you are having to a more greener alternative which you can do. So alternate feedstocks, future investments in hydrogen production, carbon capture, and those kind of things, and also future product streams. So that's what you're evaluating from a planning perspective as to what makes economic sense. And this you are able to do by considering scope 1 carbon flow, scope 2 carbon flow, and scope 3 carbon flow. And having done that, you actually do then a master planning and then rapidly evaluate process designs, new process designs based on this master planning. You engineer on time and on budget execution of your net zero driven projects, and then you achieve full and stable throughput on time and do a final handover. And all this is enabled by the engineering side, the efficient execution of your engineering projects. On top of that, if you allow me, what you have to do is layer a system of enterprise information management and visualization, which can pretty much be your current systems, and you can revitalize them to make this kind of a reporting possible. So you can track your current emissions, you can generate a decarbonization roadmap and put it on your management dashboards, based on the evaluations which you have done. You can track how those projects are going and track those initiatives, and then also do all kinds of sustainability reporting. So that kind of completes the view. I would finally like to share some client examples, because these are things not there in future, as my talk was based on repurposing the existing applications. These applications already exist. People are using them in the way I have described it. The first example is of unified production and emissions management. It talks about a client who was able to unify their production accounting and the loss management and curtail this much loss by 50% and a CO2 reduction of 10,000 tons. And that's quite a common number. Normal, typical, let's say if we pick a petrochemical plant, the losses would be, the loss would be 0.5% or maybe 0.6%. And a best practice number would be around 0.2, 0.25%. So there's always the gap of improving it by that much. The second example is of optimization. You can see the amount of energy saved, quite a big reduction in energy, CO2 emission, and a ROI of less than 6 months. So another example of optimization, carbon-aware planning. This is a global oil major who are using their planning tool and repurposing it to evaluate future projects and determining their path to decarbonization. And this example is on engineering and project, unified engineering and project, where again, a different oil major, they have executed the full portfolio and been able to take control of their projects and reduce significantly on the engineering man-hours. And some of these examples you could see in the booth out there, where you can actually get a feel of how you can get the control, 100% control of what's happening on your project, where is which part is due for delivery, and you can get that kind of an understanding. And finally, a word on AVEVA. As you saw, the kind of architecture which is needed to take you to your net zero journey, AVEVA is capable of providing you this entire kind of a portfolio, starting with industrial information management, design and engineering side, operations control, production optimization, and those kind of things. And on top of it, we can provide you a visualization as well. Thank you.